Come light it up, I'm ready to go. Come light it up, come light it up, I'm ready to go. Come light it up,
Thanks so much, Monica, and thank you, Starburst, for having me here at Data Nova. Really looking forward to our conversation today. I'm Jed Doherty, and I'll be walking you through today how you can get in the driver's seat of your AI industrialization. Start off with a little bit about me, just so you know where I'm coming from here. I started with Dataiku a long time ago now, 7 years ago. I was the longest running American employee. We're a French company to begin with. And while I've been here, I've had a lot of different roles. I started as a data scientist, went on to lead the data science practice in the United States. I built out our field engineering team and our support team. And now I'm the VP of platform strategy, where I try to help, clients with their platform strategy, as well as helping internally to decide what we're going to build next, which kind of tools we're going to integrate with next, such as Starburst. So going through the agenda, I'll give you a little bit about Dataiku so you understand where we're coming from. Then we'll dive into the existing challenges that happen when you're trying to leverage AI within your organization, when you're trying especially to institutionalize it or spread it across the full organization. Then we'll look at 3 ingredients to scale your AI that help you overcome some of these challenges. And we'll finally look at how Dataiku and Starburst can help you do these things. So what is Dataiku? We are a end-to-end data science, machine learning, data pipelining company. We try to help our clients. The problem that we're trying to solve for our clients is that as you start to expand data across an organization, or the usage of data, of AI analytics, there's a wide variety of personas that are going to need to leverage this. And we've seen in the past that there's been a blockage to truly leveraging data at an organizational level, because there's a skill gap there. If you only have a few dozen or a few hundred data scientists, and your entire organization is thousands or tens of thousands of people, inevitably you're going to need to let those tens of thousands of people answer questions themselves about data, build models themselves on top of data, rather than relying on your small cadre solely of data scientists. At the same time, you want to be able to have a platform where the more advanced users can collaborate and help the less advanced users evolve and grow. And that's really what we've tried to build with Dataiku. It's a collaborative platform that lets a wide variety of personas, from no code to low code to high code users, all work in the same place. We're present in many different industries and really across all sorts of spectrums. The ones that I work with the most personally are manufacturing, financial services, and pharmaceuticals. But as you can see over on the right-hand side, we really run the gamut across a wide variety of different industries. So let's think about the promise of AI. Why are we bothering to try to build this at all? According to McKinsey, their State of AI 2022 survey, the use of AI has more than doubled since 2017. Back then, we had 20% of respondents saying they had implemented AI at least one business sector. Today, that number is above 50%. A few years ago, use cases were primarily focused on risk, manufacturing, and marketing. But really today, they're spreading across every aspect of business functions. You can see some here: optimization, automation of customer relationships, lead gen automation, improved targeting, anomaly detection, risk modeling and fraud analytics. So you've got supply chain operations, you have object defects, you have a variety of healthcare, insurance applications, you name it, AI be in there and be helping to solve it. AI initiatives are really gaining traction. Early investments are paying off, and business departments are very eager to reap these benefits of AI. That said, in the past, AI industrialization is not without its pitfalls. A number of factors will present themselves very quickly on the road to AI that are significantly going to hinder its acceleration. We can see a few here. Data access and quality issues. How do you ensure that the right people have access to the right data across your organization in a governed way? Operationalization and impact. How do you ensure that the individual projects or the individual models that your data scientists or data analysts build can be productionalized? So you can imagine, for example, somebody writing a bunch of Python in a Jupyter notebook, sitting on a laptop somewhere, working on some static data, and then they think their job is done because they have a high enough, R2 score, or high enough AUC. What happens to that afterwards is a question that, until maybe a year or two ago, data scientists weren't thinking about very much. Lack of visibility and control, ensuring that we have an overview of deployed analytics projects and an overview of where projects are within the cycle. You can kind of think of Jira for data science or Jira for AI. Misused data experts. Here I'm really thinking not just about machine learning experts or very strong coders, but people who understand the data that is being used for development. So this is often, data experts are often business users rather than your hardcore data scientists who might be machine learning experts, but don't know the actual history of where this data is coming from. And then finally, your infrastructure costs and your infrastructure scope needs to be constantly modernized. Otherwise, it's likely that it won't keep up with new AI initiatives. So for example, GPUs are obviously all the rage right now with the advent and expansion of deep learning. If you had purchased a bunch of on-prem servers 5 years ago, you probably wouldn't have purchased a bunch of GPUs for your machine learning teams, whereas now that's a very important part of the data stack. We can imagine that organizations are going through this type of growth. When we surveyed a lot of our clients, many are at the 10 models, some are at the 100 models, and a very select few are scaling upwards to that 1,000+ models. However, all of the ones at 10 want to get to 100, and all the ones at 100 want to get to 1,000, and they're moving along that line. So this is the process that many organizations are going through right now. In the initial stages, you'll get some encouraging early results. It's often relatively straightforward to manage AI with only a few data scientists and a few use cases. There's few models. The teams responsible for it are centralized. They're all working together. However, as more models go into production, it becomes increasingly challenging to identify which ones are performing effectively, which ones require retraining. Because they don't have the right practices or tools that are too sophisticated or not automated enough, teams have ended up losing efficiency. Next, as more users and business leaders adopt the models, the hidden costs associated with inefficiency become more prominent, and they hinder the expected profit. While the values of the very first models emerges in some departments, analysts and business leads will always be looking for more use cases and models to reap the benefits in their own departments. If nothing is done, saturated AI teams won't deliver AI projects on time. Shadow AI will rise, and you don't want to live with the negative effects of ungoverned AI systems, just as you've experienced the negative effects of ungoverned IT systems. As this goes on, the deficit is going to continue to grow, leaving organizations with uncontrolled costs, time wasted, and exposed risk of being fined for non-compliance with data regulations. Paralyzed by inefficiency, you will have no more time to devote to innovation, to what makes them different, and will find themselves without control of their destiny. I was just actually talking to a client earlier today who the biggest concern that they had wasn't in building successful models, but that so many people were building models in different tools that the actual deployment of those models was going to cost them a ton of resources because they were going to have a team managing the deployed models for every different tool that they were working in. And they were really, really interested in how can I go about ensuring that models built across my organization can be deployed in a coherent way. So how can we prevent this? How can we be the transformer and not the undertaker of your analytical projects? You need to build a long-term profitable approach to scaling AI while keeping control and oversight. What does that end up looking like? You need to maintain a balance of speed and control. Speed, providing teams autonomy, providing teams the tools that they need across different skill sets. You need to be able to measure your business impact. And yes, you need to provide the capabilities to work with AI to the widest amount of people possible. On the other hand, control means we need to manage cost optimization. We need to manage security. We need to manage governance. So security can be access to data, access to models. Cost optimization is obviously not blowing through your cloud spend. And governance, we often think of governance as equaling security, but what I really mean by governance is keeping track of these projects and how they're going, what's working, what's not, what the ROI is per project, all of those kind of questions. So how do we move from the experimental stage to the industrial stage? Let's look at a few key parameters that can help bring your AI efforts to the next level and make them more industrialized. At Dataiku, we try to define 3 key steps to tackle the challenge of AI industrialization. First, we want to have an adaptive platform. So an adaptive platform means a platform capable of leveraging your existing investment, relying on the cloud to meet volume constraints that an organization may encounter. That is to say, the limitations of volume, seasonality, and constraints related to the various users who will have access to the platform. Next, we want to be able to accelerate the time to value. It's not enough to just provide tools. We need to go a step further and ensure we're bringing value to the business teams. Making AI a team sport means circulating data within the company and allowing everyone to take ownership of it. It also means relying on industry expertise to accelerate when necessary. Where I see accelerating the time to value is indeed not just in sharing data, but we often see that the more advanced users will be building plugins or other stepping stones for less advanced users. So instead of a single, a very expert data scientist building out a single project, which they have, and then going on to the next project and the next project, a very advanced data scientist can build out a template or a structure for less advanced folks, and then you have a product multiplier there where many people can use the initial work that first data scientist has done. Finally, installing trust in your company. So trust in AI projects is a very tricky thing. If a project has been built without the insight or the assistance of business users, and then they're expected to rely on the results of this project, we often see a lack of trust in what the AI might be telling them. By having business users embedded in the construction of your AI workflows across the span of those building blocks, they are now invested in the results just as much as the data scientist might be. In addition, they often capture things that the data scientist fails to do. A funny thing, a little anecdote, if anybody remembers the Kaggle competitions, which were all the rage a few years ago, often, or almost always, in fact, the winning teams of Kaggle competitions, the teams that ended up with the highest scores, usually were getting the highest scores over the other competing teams, not because they were delivering deeper insights from the data that was offered for each competition, but because their models were identifying essentially defects in the way the data was anonymized, or structural changes in the way the data had been collected. So they weren't actually helping to predict ground truth changes or ground truth results. They were just predicting the flaws inherent in the data itself. Business users would be able to see that models were not actually predicting reality, whereas pure data scientists might just say, well, I don't know, my score is high. What do I care? Let's put it into production. Having that ability to converse back and forth really is important. And it's critical for trust and critical for the quality of your models. Just like a Formula One car designed to perform its best in any conditions, an adaptive platform should be able to handle an increasing amount of computing power in any configuration without degradation in performance. So this adaptive platform also means scalability. We want to have an infrastructure that can handle 1 user, 10 users, 100 users, 1,000 users, and ideally one that scales up and down. So if you don't have 1,000 users working at once, you're not paying for the resources that would require. So what are we hearing from our clients? They're often asking, how can I leverage my past investments and innovate at the same time? They're asking, how can we evolve our system to adapt to time and load constraints? And they're asking, what if I could finally succeed in democratizing analytics for everyone? What would that bring to me? So for combining past investments, they're really concerned with taking advantage of the cloud, which is now exploding. Obviously, everybody's moving to the cloud, but a lot of people have built a massive on-prem data warehouse, massive on-prem amounts of compute, modeling, code, etc. How can they continue to use those while moving to the cloud? How can we make sure that we can scale? And how can we make sure that as many people as possible can use the infrastructure that we're building in the cloud right now? Well, having an adaptive platform is really helpful. With Dataiku, for example, you can deploy regardless of the location where you might be wanting to build out. So many of our clients, probably 40% of our clients, still have an on-prem footprint. They're often deployed on the edge of a Hadoop cluster or deployed on, I don't know, a giant GPU box they've recently purchased, DGX or something like that. Whereas 60% of our clients are deployed in one of the 3 major clouds, Google, Azure, or AWS. We work with all 3. We've often helped clients, if they've built out a large workflow on-prem, we've helped them migrate to the cloud. Because with Dataiku, the same project, you can swap out the underlying compute or infrastructure while keeping all of the components in place. Dataiku works with the popular underlying databases, such as Starburst, as well as providing its own elastic compute layer for running Python and Spark and R jobs. And then finally, Dataiku provides a common grammar of data. Workers or employees from different teams, if they're using Dataiku, can all be talking about the same concept of data sets, recipes, services, integrations in that way. The flow is a common way of speaking about how you build out data. So this allows communication between teams that often otherwise would not have anything in common. It makes it far easier also for teams to learn from each other. If I have a great flow, I can share that flow with a different team or with other colleagues, and they can learn from it, copy it, etc. So how do we go about getting 1,000 people to build 3,000 data and AI projects? Let's think about what we need to do to transition here. Originally, you probably have a very complex legacy infrastructure, think Hadoop. You may potentially have redundant data silos and slow collaboration. So maybe you've got stuff saying, I mean, this happens all the time, right? You got a SQL Server over here, you got Greenplum over here, you got some Redshift, you got XYZ all over the place. And the inability of practitioners to own their own analytics. All right, so I know I have an idea or I need to pull this data from somewhere. However, I need to first ask 10 different people for permission to access the data, and then I actually need to send somebody else over here to write the SQL query for me. That's all friction that we want to try to get rid of. Afterwards, for example, here we talk about Azure, but it could be any of the clouds, some kind of hybrid architecture that's leveraging both Azure as well as on-premise technologies, real-time collaboration on a platform spread across potentially 40 different countries, and 2 to 5 times the delivery of data projects. So we're building data projects much faster by leveraging this collaborative platform. This was a pharma organization that I worked with very closely, actually. So let's look in more depth about accelerating the time to value now. What are we hearing from clients again for time to value? How can we remove barriers in the life cycle of our AI projects? How can we encourage domain experts to take data ownership without data chaos? And finally, how can we create immediate value without starting from scratch every single time we build out a project? So we can start by eliminating friction from our processes by having ML ops in a centralized location where we can ingest models built in multiple different places, manage the deployment of those models, the monitoring of those models, and then the rebuild and update really allows you to adapt and be confident that the models you need will be around at the time that you need them. We can also make the best possible use of reliable data as soon as possible in order to have a competitive advantage. To do this, we need to collaborate with data teams, business teams, and allow them both to be autonomous in the creation of data projects. Leveraging collaborative features within the platform, such as our workspaces, data collections, data labeling, all allow business users to start building and sharing data products autonomously. So when we hear about feature stores, things like that, all of that ends up making business users more able to build out their own workflows. And then we can also think of lots of different ready-to-use accelerators. So problems within a given industry often have pretty easily reproducible business solutions. So having pre-built versions of these, which Dataiku does have built into its tool, allows organizations not to just 100% yank and start leveraging, but it does allow them to have a starting point which they can adopt or slightly adapt to their own idiosyncrasies or processes. So what happens when we start delivering these kind of capabilities? Here we'll talk about a global bank that Dataiku worked with recently. Before, they had a legacy infrastructure that was incompatible with the real-time scoring or real-time data flows. They were spending a lot of time getting results. They were waiting 3 months. They would build out their workflows in Python, and then they would offshore the Python workloads to a consulting firm offshore. This consulting firm would then rewrite the workflows in Java, send it back to the analyst. The analyst would take a look. They would often be incorrect. They'd have to send it back. And you'd have a 3-month gap between when the analyst felt they were done with their side and actually being able to leverage the data regularly. And finally, there was no central way for this bank to be able to identify and predict where problems were going to arise with individual projects. After building in Dataiku, they were able to provide twice as fast model scoring, near real-time response, and they were able to scale up to 15 million scoring calls, all while building the workflows much, much faster and without needing to have 2 different teams that had challenges communicating with each other, building these workflows out. Let's look at the last one here. driving our projects with trust. So what are we hearing that makes this important? Clients are asking us, how do we remove barriers in the lifecycle of AI projects? How do we encourage domain experts to take data ownership without data chaos? And how do we create immediate value without starting from scratch every time? We want to make sure that we're prepared to meet any regulatory requirements that may come up as well. So that's something we want to keep track of. So addressing these challenges require a specific approach that we'll look at right here. So what do we want to do in order to drive these projects with trust? Driving control with trust means it's not just about keeping an eye on the models themselves, but also on the platforms where the models are deployed. This includes things like identifying advanced and preventing bottlenecks, checking for overload, optimizing processing, and monitoring consumption. All of these are crucial for ensuring the success of your projects. It's not just about monitoring individual projects, though. It's also essential to have a unified and centralized view of all your analytics projects and deployment, so you can keep track of what's working, decides if any enhancements or retraining is needed. I've had situations with clients where a client has deployed a model, but they had never done a deep ROI analysis of this model, meaning how much is the model costing me to keep deployed, to keep monitored, versus how much money is this model actually making me by providing additional insights. Sometimes you do that investigation, you do the analysis, and it turns out even if the model has high accuracy, high precision, high recall, whatever, it's not worth keeping in production because the cost of keeping it there is higher than the money it's bringing in. And finally, building transparency at enterprise scale. We want to make sure that we can explain exactly why our models are making the choices they're making, and also be able to be transparent about who is accessing these models, who is accessing this data, how often they're doing it, and how all of this was built. So having a full and complete audit trail of both who's leveraging your models as well as who's building out these workflows is critical when the regulators come a-knocking. Being able to deploy or build out documentation automatically of both workflows as well as specific models also is critical for speeding up and avoiding having regulatory drag bring down your projects. Let's look at a real-world scenario. So here I'm going to be talking about Aviva. It's a big insurance company, Dataiku, longtime client. This is how they managed to improve the monitoring and resilience of their IT department. Like many organizations, they have a ton of IT assets, processes, and support teams to manage, and they're always looking for ways to streamline their operations and improve efficiency. To address these challenges, Aviva created the Digital Operations Management Engine. Sounds very fancy, which uses various tools and techniques to analyze and optimize its IT operations. One key component of the DOME is Dataiku. It enables Aviva to extract insights and value from its data. With Dataiku, Aviva has developed several use cases to help them better understand and manage their IT operations. For example, they've used natural language processing to classify incoming incidents and identify potential root causes with 97% accuracy. They've also used unsupervised machine learning to detect anomalies in log data and alert the support team. Finally, they're using semi-supervised learning to predict cluster failures up to 3 hours in advance. The DOME has generated significant value for Aviva. It's helped them to increase operational and resource efficiency by reducing the time it takes to resolve incidents and to identify root causes. And it's also improved the customer experience by proactively detecting and fixing issues with their IT estate. And it's improved service availability and reduced incident rates by helping the support team take preventative measures to avoid cluster failures. It provided the benefit of around 200 hours in effort per month and around 700 hours of mean time to resolution savings per month. Overall, DOME has been a valuable addition to Aviva's IT operations, helping them streamline processes, improve efficiency, and deliver better customer service. It's all thanks to the IT team's leverage of a platform like Dataiku to help extract insights and value from their data. So let's take a couple minutes to review the key takeaways from our discussion. 3 parameters to deliver AI at scale: have an adaptive platform, accelerate your time to value, and drive projects with trust. We want to make sure that We have the hardware, software infrastructure, and the ability for end users to actually leverage that infrastructure. That's our adaptive platform. We want to make sure that the things that people build within that platform and infrastructure can be reused and don't need shifting from one team to another without any real communication between those teams in order to build them. And then finally, we want to make sure that we limit risk and ensure that we are properly monitoring the projects that we build and deploy. Dataiku, of course, does take security very seriously. We are GXP compliant, ISO 27001 certified, SOC 2 Type 1 certified. We're working on Type 2 right now, Cyber Essentials certified. All of this ends up being really important as you start deploying in more regulated industries. So thank you so much. If you have any questions, please feel free to reach out, and we will talk to you soon. Bye-bye.